Assalamu alaikum. I am Jahangir Alam, lecturer in physics at Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class, and I am carrying on my regular activities. Dear students, I also hope all of you are well with your family members by the mercy of Almighty and carrying on your regular studies, staying at home. Right, dear student, in our today's class, we are going to discuss some important topic from the 9th chapter of your physics book, that is the chapter of refraction of light. Right, mainly today we will discuss on the practical uses of refraction of light. Okay, mainly today we will discuss on critical angle, total internal reflection, and practical uses of total internal reflection, that is optical fiber. Optical fiber is playing a very important role in our today's telecommunication system or IT sector. Okay, dear student, so let's start our class. Dear students, first we are going to discuss the critical angle and total internal reflection, right? So dear student, first observe this figure. Here are two mediums, one is rarer medium and another is denser medium. There is a difference in refractive index between the two medium. First, I would like to remind you that when light passes from a rarer medium to denser medium, in case of refraction, the refracted light will or refracted ray will move towards the normal. That is, the angle of refraction will be smaller than the angle of incidence, right? But on the contrary, if the light enter from the denser medium to rarer medium, right? This figure describe like that phenomena. Suppose this is a denser medium and this is rarer medium. Light is entering from denser medium to rarer medium. First we consider the green light, that is the light entering from denser medium to rarer medium, and from the law of refraction, the refracted ray will move away from the normal. In that case, the refracted angle for the green light will be greater than the incident angle in the denser medium. That is, the angle of refraction will be greater than the angle of incidence between the two medium, right? Dear student, if you increase the value of the incident angle in the denser medium, that is for a certain value of the incident angle which is denoted by the red light, when the incident angle move away from the normal from green position to red position, that is the angle of incident increases from I1 to theta c. So in that case, the refracted angle will be also increased than the previous value, and for a certain value of the incident angle, that is which is denoted by theta c, the angle of refraction in the rarer medium will be 90 degree. That is, the refracted ray will pass through the or pass along the plane of separation between the two media. Okay, so in that case, the refracted ray will neither pass in the rarer medium nor in the denser medium. It will pass through the or along the plane of separation. So in that case, the angle in the denser medium will be known as critical angle between the two media, right? So what is called the angle? This is called critical angle between the two media, which is denoted by theta c. Okay, dear student, suppose in that case, if the refractive index of the rarer medium is denoted by eta 1 and that of the denser medium is denoted by eta 2. So from the laws of refraction, from the laws of refraction, theta 1 sine 90 degree equal to eta 2 multiplied by sine theta c, right? In case of critical angle, the angle of refraction will be 90 degree for the red light. So eta 1 multiplied by sine 90 degree equal to eta 2 multiplied by sine theta c. So dear student, you can rearrange this equation eta 1 by eta 2 is equal to sin theta c divided by sin 90 degree. Okay, so sin theta c divided by 1, you know the value of sin 90 degree is equal to 1. Therefore, eta 1 by eta 2 is equal to sin theta c. That is, student, this is the relation between the critical angle and the refractive index of the two media. Here eta 1 is the refractive index of the rarer medium and eta 2 is the refractive index of the denser medium. But in practically or in your question, often you will find that the refractive index of the denser medium with respect to rarer medium will be given in your question. This indicates, this portion or this fraction indicates the refractive index of the rarer medium with respect to denser medium. So eta 1 divided by eta 2 indicates the refractive index of the rarer medium with respect to denser medium. But in most of the case, the refractive index of the denser medium with respect to rarer medium will be found in your question. That is, in question you may find that the eta 2 divided by eta 1. So in that case we can write 1 by sin theta c. So dear student, this is also an expression relating the critical angle between two media and their refractive indices, right? So this is a very important equation to solve some mathematical problem, right? I hope you got it. Dear student, now we are going to discuss another important part or in another important topic of this class, that is total internal reflection. You know, when the critical angle of the two medium, that is, when a light incident at a critical angle between the two media, then the refracted ray will pass through the plane of separation. Dear student, if you would like to increase the value of the incident angle in the denser medium, that is, if the angle is more than the critical angle between the two media, which is indicated by the blue ray, and the angle here is more than the critical angle, so in that case the refracted ray will move away from the normal. So angle of refraction will be more than the previous value. So in case of theta c, that is, in case of critical angle, the angle of refraction was 90 degree. If the incident angle is more than theta c, then the angle of refraction will be also more than 90 degree. So if the angle is more than 90 degree, then according to the rule of reflection, the ray will come back to the denser medium, right? So in that case, the 100% light will reflected to the denser medium. That's why this phenomena is known as total internal reflection. In normal reflection, a portion of the incident light reflected back to the first medium. But in this situation, total or 100% light reflected back to the denser medium. So this phenomenon is known as total internal reflection. So in a present day, we have many uses of total internal reflection in our communication system and telecommunication system, right, or IT sector. Okay, dear student, now we will see the definition of critical angle and total internal reflection. These are two very important definition of this part. Okay, so dear student, according to the definition of critical angle, they said that when light passes from denser medium to rarer medium, that is, light need to passes from denser medium to rarer medium, then for a certain value of the incident angle, the angle of refraction becomes 90 degree. Okay, this angle of incidence in the denser medium is called critical angle between the two medium. And total internal reflection, when light passes from denser medium to rarer medium, then if the angle of incidence is more than the critical angle between the two media, then the incident angle totally incident light totally back to the denser medium. This phenomena of light is called total internal reflection, right? These are very two important definition. And now we'll see the condition for the total internal reflection. The first condition is the ray of light must be incident from the denser medium to rarer medium, and second condition is incident angle must be greater than the critical angle between the two medium. right? Dear student, I hope you got it. This is a very important of this part. Okay, so you need to memorize these two definitions. Dear student, now we are going to discuss a very important part of this chapter, optical fiber, right? You know, in the past, the information or signals of telecommunication are sent with a electrical wire as a electrical signal. But in the present day, we are using or we are sending the messages or signals as light signal using a special device, using the special property of refraction of light, is the property of total internal reflection. And this device or system is called optical fiber, right? Actually, optical fiber is a soft, flexible glass tube with which total internal reflection takes place, right? Dear student, suppose my marker indicates the optical wire or optical fiber, and a special coating will be remain with the over the optical fiber. That is like the figure. This is the optical fiber. This is a flexible thin glass, and it is coated with a special type of material whose refractive index is less than the refractive index of the glass. So inner part of the optical fiber is called core, and the outer part, that is coating of the optical fiber, is called clad. In that case, the refractive index of glass and clad must be less or smaller than the refractive index of the core. So in that case, when light incident in the medium and incident on the plane of separation, it seems to be like that light is entering from denser medium to rarer medium. So according to the laws of total internal reflection, if the incident angle is more than critical angle between the core and clad, then it will be totally reflected to the core, and the reflection will be continued up to the last end of the tube or optical fiber. So optical fiber is a glass tube through which total internal reflection takes place, and the light will passes from one end to other end without any diminution or losses of energy. Okay, dear student. So now we can give the definition of optical fiber. Okay, dear student, here is the definition of optical fiber. So optical fiber is a very thin glass in which total internal reflection of light takes place. Okay, it's a very important and easy definition. Dear student, now we can see a short video for our better realization about optical fiber.
Total internal reflection is important in technology. A lot of communications are done, including telephone and other communications. You may have an optical cable in your home stereo or home theater system that communicates audio information through an optical cable. The principle is total internal reflection. If we come in at a glancing angle, then all of the light that's incident on this surface and on this surface will be reflected back internally into the material. So it works for glancing angles, and the beam needs to be confined within a material that is more optically dense, has a higher index of refraction than the surrounding material. But any shape will do. You can use a rectangular shape here, you can use a circular shape, confining all that light inside of that fiber. This is a more typical light optical cable or light fiber. I'm just going to introduce the beam here. You'll see it come out on the far end. This is an example of, we have a source of light in the base here, and each of these, all they are strands of plastic, and they are channeling the light through them. And they can be bent or whatever, and they'll still channel that light. There is a certain radius. If you bend it, if you kink it really hard, then that brings you away from the total internal reflection.
Right, dear student. Now we'll see an important and interesting thing, that is mirrors in desert. Dear student, you know, in the desert, the sun become very hot at the daytime by the sun ray, and the layer of air adjacent to the sun become very hotted and expanded, right? So the next layer of the air become expanded a little small less than the first layer, that is which is adjacent to the sand, and consequently the third layer will be expanded little more less than the second layer, and that for the fourth layer. Okay, there is shown. So we can say that the first layer, which is adjacent to the sand, is optically least denser. That is, the density or optical density of the first layer, which is adjacent to the sand, is very small or very less, and that of the next layer will be a little more than the first layer, and that for the third layer will be little more than the second layer, and so on, right? So in that case we can say that this layer is very less denser, and that is more denser than the first layer, that is the third layer is more denser than the second layer, and fourth layer is more denser than the third layer. So when light enter from any object or any tree to the fourth layer, and when it pass from the fourth layer to third layer, then that is, we can say that light are entering from denser medium to rarer medium, because this layer is more denser than this layer. So when light enter from denser medium to rarer medium, then you know, according to the refraction, light will away from the normal, and when light will enter from the third layer to second layer, this same phenomena will happen in that case. So light will move away from the normal, and when light incident on the second layer or plane of second layer, if the angle of incidence is more than the critical angle between the two layers, in that case a total internal reflection will take place, and the light totally will back to the upper medium. And if the reflected light falls on the eye of a person, then it seems to person that the light are entering or light are coming from this point. So a person at the same time he will see the real object, at the same time he will see the real object, and he will see an virtual image of the real object. So it seems to person that there is a water body near the tree, right? So this phenomena is called mirrors in desert.
Now, seeing water on a highway is one thing, but imagine a thirsty traveler traveling in a desert. He sees water. There is nothing more miserable than that, right? Let's understand why this happens. Basically, what happens is, during day the land becomes hot. Because of that, the air molecules above are warm. But as you go up, it keeps on becoming cooler and cooler. That means, right now at this level, if I hold my hand like this, I can clearly see the difference. That is, my lower hand is much more warmer in comparison to the above hand, which is much more cooler. So what we have understood is the layer at the bottom is more warmer, but as you go up, it gradually keeps on becoming cooler and cooler. Now, the light from the sun hits the object. The tree there is the object. After hitting the object, the light will reflect and it will enter the first layer. Now, the first layer is denser. Now, as and when the light is going from denser to rarer, it will keep on bending away from the normal. So, at each layer, what you see is the light is bending away from the normal. But at one point, what you will notice is light will hit at an angle which is greater than critical angle. And at that point, instead of light undergoing refraction, the light will undergo total internal reflection and enter my eye. Now, once it enters my eye, human eye always perceives that light always travels in a straight line. So now I can see the reflection there at the bottom. So the reflection of the tree is there. Similarly, the reflection of the cloud is also seen there, and that appears like water. So that is how mirage takes place.
Dear student, now we will see prism. Right? What is prism? Actually, prism is a transparent medium bounded by three inclined planes. Okay? And again, you know, white light consists of 7 colors, and the colors are violet, indigo, blue, green, yellow, orange, red, which is shortly known as VIBGYOR. Right? When a white light incident on the on surface of a prism, then according to the law of refraction, there a refraction will take place in the plane of separation, and the 7 constituent color of a white light will be resolved into the constituent color. That is, a white light will be resolved into 7 constituent color. So if we place a screen on the opposite side of a prism and a white light is incident in the other side of the prism, then you will observe there are 7 color. So we can say that prism is a transparent medium which can resolve the 7 constituent color of a white light. Okay, dear student, I hope you got it.
This is an example of a prism being used as a spectrograph. In other words, used to separate colors. The prism is the triangular object in the middle, made out of glass. From the bottom left, you see the incident beam of light, which is white light, and towards the top, it's partially reflected. But within the prism, the white light is refracted, and then when it hits the surface to the right of the prism, it's refracted and dispersed.
Dear student, now we will discuss on periscope. You know, periscope is a device which is used in submarine. Okay, so actually today we are going to discuss the mechanism or working principle of a periscope. In periscope, there are two mainly the working substances to prism. In the periscope, there are used 2 prisms, and the prisms are set in such a way that when light enter in the first prism, due to the total internal reflection, because the surface is such a way set that when the light incident on this surface, the incident angle is become more than the critical angle between the 2 mediums. So due to the total internal reflection, the light ray of light is transferred to the second prism, and for the same reason, that is due to the total internal reflection, it reflects back to the eyes of the viewer. So remaining or keeping himself inside a submarine or under the water, he can observe the object above the water level. So this is the mechanism of a periscope. Okay, this is more powerful than the normal or ordinary periscope made by the reflecting or periscope made by mirror. Dear student, here I hope all of you have observed the rainbow, and you know what rainbow is, but many of you do not know how rainbow is formed. Dear student, so today we will see or discuss about how a rainbow is formed. Dear student, after the heavy rain or rainfall, you know, there are many water droplet or water particle in the atmosphere, and every water particle or water droplet act like a prism. And you know, in the prism, white light can be resolved into 7 constituent color. So when light from the sun falls on the water droplet or water particle, it resolves into 7 constituent color, and due to the resolution of 7 constituent color, we can see a rainbow or 7 colors in the horizon. So this is the mechanism of rainbow formation. Okay, dear student, this is all about our today's class. I hope you enjoy it, and you need to practice from your textbook. Dear student, thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.